Hello, good morning, good afternoon, and good evening. My name is Kisoo Kim from POSCO. I am responsible for manufacturing processes and engineering, including smart technologies. First of all, let me thank you for inviting me to share our experience on smart technology, which has been done for the last 6 years at POSCO. Today, I'm going to show you some milestone examples of AI, artificial intelligence application in steel works. I like to focus on AI and human ensemble operation in steel manufacturing processes. Before we get started, let me briefly talk about the AI history of POSCO. In fact, we tried a neural network in the middle of 90s, but it did not work very well at the time. So we thought that AI would not be a solution for smart factory or automation of steel manufacturing processes because of the lack of data from the works, and even data quality is not good. But there was an AlphaGo event in 2016 in Seoul. That was the turning point for us, and we set up several pilot projects for AI implementation in the steelworks. At the moment, we got more than 100 AI algorithms operating in our works. That is a really big change. In this talk, I'd like to show you some of examples of AI application. Before we move on, I'll just share the situation of POSCO as a steel manufacturer. The steel production has been rapidly increased for the past 200 years. Steelmaking technology has been focused on improving productivity and efficiency. As a result, crude steel production increased more than 400 times compared to that of 1850, which is 1.8 billion tons. However, technological development has been saturated in terms of hardware and productivity. Steel technology is facing the moment of paradigm shift. Definitely, the environmental issues like global warming has become the crucial common issue. So what will be the innovation for the future in steel works? Looking at Korean steel industry, we are on the maturity stage. It is very difficult to find a growth engine for the future. In the Korean steel market, steel consumption is more than 1 ton per capita, the highest in the world. Currently, crude steel production is about 71 billion tons, but I think there will be no more growth in the future in terms of production capacity. In summary, let me tell you about 4 major challenges. Probably all steelmakers are in the same situation. First, global oversupply. Second, as I said before, we should follow environmental regulations to achieve carbon neutrality. And it is expected that the price of steel will increase when green steels come. In safety, in spite of the great efforts, the number of fatal accidents has not decreased significantly. Lastly, the baby boom generation are retiring, which means high-skilled operators or engineers are leaving soon. We are losing the know-hows in the workplace. We need solutions that can solve all these problems, and smart technology can be one of them. That's the background of Smart Factory at POSCO. Our definition of smart technology is combining domain knowledge and ICT technology, including AI. It will be creating new values and further building an intelligent steel mill. The intelligent steelworks starts from sensing, in other words, creating and obtaining data. In our experience, in many cases, The key data needed to solve a problem can only be obtained by developing and installing new innovative sensors. We need to have clean and quality data from the noisy and dusty mills. Big data, numbers like temperatures, including even pictures and voices, is the basis for machine learning. These data are the feed for AI algorithms that can make a decision for a better performance. By using these technologies, we would have autonomous operations in steel works. For example, automation in 4D tasks, dull, dirty, dangerous, and difficulty to minimize human operation. POSCO has been applying AI models from marketing, manufacturing, to even safety. At first, we have started 4 pilot projects and gradually diffused them to other sites. We are leading the AI technology for intelligent steel mills by continuously making success stories of these AI models. As a first example, I will show you the Smart Blast Furnace project. 100% of blast furnaces were operated by human and by operators' experience and intuition. They have to think about raw materials, temperatures, air pressure, signals from blast furnaces. Too many things for human operators. Therefore, there is a deviation in operation depending on the level of operator's skill. To overcome this, so many IoT sensors have been installed to obtain new data. Now we are automating blast furnace operation by generating high quality data on ore and coke quality, air volume, and coke usage ratio, etc. We have also developed 5 AI prediction and guidance models. This makes it possible to always keep the blast furnace in a normal condition. During the development, we have realized that data quality is the key factor for autonomous operation. It's not algorithm, it's not amount of data. If we have very nice and clean data, half of the whole work is done. The success of the Smart Blast Furnace was possible because of active collaboration between engineers, researchers, SMEs, and universities. Steel manufacturers have domain knowledge, and AI algorithms come from universities. How to join them together is the key to find a solution for having AI operators. For sensing data, we have relied on SMEs who's got the sensor technology. It is found that Smart Blast Furnace has shown 5% productivity improvement, 1% cost reduction. It is noted that carbon dioxide has been reduced by 1%. After finishing the Smart Blast Furnace project for a medium-sized one, new AI models are being developed for other blast furnaces. Further, operators are satisfied because their burden has been relieved a lot. Currently, these technologies are being applied to other bigger blast furnaces. Let me show you another project in downstream processes. Smart cial, continuous galvanizing line, has been chosen for developing AI model. Hot dip galvanized steels are products in which zinc is coated with a thickness of 6 to 25 microns to prevent the corrosion of base iron. The coating thickness is controlled using an air knife device located near the molten zinc part. The operators control the air pressure and gap of the air knife to obtain steel strips with a desired uniform coating thickness. However, the time delay between measurement of zinc coating thickness and operator's judgment of air knife conditions causes a non-uniform thickness of zinc coating layer. It is because the measurement of the thickness of zinc layer can be possible only after solidification. So the thickness measuring sensor should be installed almost 200 meters away from air knife. So there is always a difficulty in controlling the thickness of zinc layers. It's like a blind driving without data. So AI model has been developed first time in the world to predict the zinc coating thickness with a high accuracy instead of human operators. After introducing AI models, the deviation of coating thickness has been reduced by 65%, and the amount of overcoating has been reduced a lot by 50% as a result of the better performance of AI operation. After finishing first project, all of the CJ line have been connected by a system called AI Zinc Master. That is like a big brother for CJ lines. AI Zinc Master system has controlled 16 factories around the world, and it improves the performance of AI models in all factories. That means one AI operator with global one quality. Operators from China, India, and Mexico are just watching and monitoring. Globally, the same level of coating quality is obtained, and we can monitor AI's performances and upgrade AI model by machine learning remotely. Let me draw your attention that we can reduce the material cost by up to 85% in the CGL in Mexico. In particular, I'd like to point out that under the COVID-19 situation, global 16 coating lines are now being controlled remotely without traveling or visiting factories in China, India, Thailand, and Mexico. Prior to COVID-19, it took 7 to 10 days of business trips and factory visits from Korea to Mumbai in India to solve on-site problems. During the COVID-19 situation, data collecting and remote controlling by AI Zinc Master almost in real time can be possible without face-to-face meeting. Digital twins are also our main R&D activities. 3D-based design, VCS, virtual commissioning system, and VTS, virtual training system, are developed for engineering and education or training. It is expected to reduce engineering time and cost. These are the basis for building virtual factories synchronized with physical assets. Now I'd like to show your smart predictive maintenance system called PIMS, POSCO Intelligent Maintenance System. This is developed to predict facility failures using AI technology equipped with various IoT sensors such as sound, video, thermal image, vibration, motor current, etc. We hope to have preventive maintenance before having failures. Smart safety solution is one of the key tools for zero accidents in workplace. As an example, I'll show you the smart safety ball that has been developed for 3 years. Before entering the confined area, people can throw or roll the ball into the hazardous space or a room to detect oxygen, carbon monoxide, and hydrogen sulfide. This tennis ball size smart gas detector can be used for 2 years without battery replacement by using BLE technology, Bluetooth Low Energy. Using a smart safety ball, it is now possible to detect gas before entering the enclosed space by checking gas concentration displayed on smartphones. Imagine data can be received from a distance of 30 to even 100 meters. The experience of 6 years of more than 100 projects of industrial AI proves that collaboration is the key to obtain successful implementation. Universities have developed AI models, while SMEs have played the role of developing right sensors to create right data. POSCO, a steel manufacturer, has provided domain knowledge from experienced engineers and operators. This is the lesson we have learned. AI is definitely a tool for the intelligent steelworks, but it's not almighty. We need to be more practical. Since AI models have firstly introduced, we have reviewed all the performances from operators and AI models. And we have learned and concluded that the full automation using AI in the steel manufacturing process is not practical. It is because database models are interpolating, not extrapolating, which means AI cannot cope with unexpected changing of operating conditions with the lack of data. Therefore, human-machine ensemble operation and physical and AI ensemble model is required rather than full automation by only AI model in steel manufacturing processes. Our efforts have been recognized, and POSCO is selected as a lighthouse factory by World Economic Forum in 2019. And we will keep trying to lead the fourth industrial revolution technology in the steel manufacturing processes. In summary, as I showed you, more than 100 AI models have been developed and operating in the steelworks at POSCO. And we have learned that AI can be a part of solution for smart factory, but full automation with AI in the steel manufacturing process is still far away. Lastly, I'd like to emphasize the collaboration is the key success factor for building smart factories. Okay, that's all of my presentation. Thank you so much for your kind attention. If you have questions, please email me anytime. Thank you so much again.